This is a video going over the last section of converting quadratic forms. We haven't talked about this in class, but this is an optional extension lesson, as you will. It says standard to vertex form. Before, we've previously covered on the last 2 pages how to go from vertex to standard, that's right here, and then how to go from factored to standard. This is just the other direction. Here up at the top, we have our steps. It is 4 steps, just like the other ones. And then I do have a typed example. The typed example does look a little aggressive. I will go over all the blanks. I promise it's really not that bad. Here at the top, it says step 1, if A equals 1, proceed to step 2. If A does not equal 1, then you have to actually do something with it. Similar to here. Remember, if A equals 1 on our vertex ones, we just immediately start multiplying. And if it doesn't equal 1, then we do have to do another step as well. Okay, so here's our example. A does not equal 1 in this one. A is 5. I'm going to label that right here, A, B, and C. At least this is our original A, B, and C. Here it says, if A doesn't equal 1, divide out A from the first 2 terms and write it as A, parentheses, x squared, plus B divided by A, x, close parentheses, and then you leave the plus C alone. The plus C did not change. And you can see that happening right here. Here was our 5, and we divided 5 out of both of these and wrote down what we had left. So right here, we divided by 5, and that got us. Step 2, find the value of B divided by 2 squared. Rewrite the problem with this value now inside the parentheses to make a trinomial. You must also subtract it from C at the end of your equation to keep it balanced. And if A does not equal 1, you must also multiply this value by A when subtracting it from C. This is the step that, in my opinion, is the most confusing. We're going to take it real slow. Now, first it said find B over 2 squared. And when it asked for that, it's asking for our new B. This would be our new B. So A, B, and C. So B is 2. I'm just going to write it off to the side. B over 2 squared. And our B is 2. So 2 over 2 squared. 2 divided by 2 is 1. 1 squared is 1. So the value we're looking for here is 1. And the directions say rewrite your problem with this value now inside the parentheses to make a trinomial. You must also subtract it from C at the end to keep your equation balanced. So right here, we're not trying to change the value of our equation. We want to keep our equation value exactly the same. So if we do a plus 1 right here, and that's where we got that from doing B over 2 squared, we have to also subtract the 1 from here, because then if you look, I actually added nothing to my equation, right? I added positive 1 here and negative 1 here, but if you add those up, those add up to 0. So they don't change anything. And then back here, we do have to multiply by A, because if you look, this 5 is eventually going to get distributed to this 1 right here. So this 1 is actually a value of 5 times 1. So that's why the 5 has to also multiply by our negative 1 right there. So it does stay fully balanced, because if you were to multiply this out, we would get 5. Multiply this out, we would get negative 5, and that still adds up to 0. Erase my stuff here. Oop, whoopsie. Okay. Perfect. Now let's look at the next step. Step 3. Write a perfect square trinomial as a binomial squared. This is in the format x plus or minus b over 2, the whole thing squared. You can also use a multiply add chart to find the binomial if you prefer. If you would like to do a multiply add chart off to the side to factor this, you can, but there is a shortcut. This, and every time we do this, is going to be a perfect square trinomial. That means it's going to be the same thing multiplied by itself. That means it's going to have x plus 1 times x plus 1, or x minus 5 times x minus 5, or 2x plus 2 times 2x plus 2. And the way we're going to find that is just do b over 2. And we're not going to square it this time. The squared is already here on the outside. So b over 2, we have that written right here. It's 2 over 2, which is equal to 1. Put our 1 in there. And then right here, we are just going to simplify the back here. 1 times 5 is 5. Okay, now it says, step 4, simplify the constants outside the parentheses. You should have now a vertex form equation. And what we're talking about is these right here. These are just constants. They can be added together because neither of them have an x attached. And this is our vertex form. And I've also written our vertex right here. Let's look at number 8. I'm just going to go back up here and read the steps. Step 1, if a is equal to 1, proceed to step 2. A is equal to negative 3, so we're going to keep doing step 1. If a doesn't equal 1, divide out a from the first 2 terms and write it as, notice C did not change, and you now can see it is beginning to look like vertex form. So I'm going to come right here. I'm going to divide just these 2 by a, which is negative 3. And I'm going to write it on the outside. Negative 3 divided by negative 3 is 1, x squared. Negative 12 divided by negative 3 is positive 4x. And remember, I keep my plus 1 on the outside. It does not change. Perfect. Now that was step 1. Okay, step 2. Find the value of b over 2 squared. Okay, we're going to go with our new b. Our new b is 4. So b over 2 squared is 4 over 2 squared. 4 divided by 2 is 2. 2 squared is 4. Rewrite your problem with this value now inside the parentheses to make a trinomial. We're going to stick it on the inside. X squared plus 4x. I'm going to put it right here. And then remember, I also have to subtract it from the back. So I have plus 4 here and then minus 4 there. I'm doing that to keep my equation balanced. I want to say that I really added nothing, right? Because plus 4 and minus 4 cancels out to 0. But here, if I were to actually multiply this out, this negative 3 is actually going to multiply by that 4. So I also have to multiply the back one by negative 3. Okie doke. Step 3. Write perfect square trinomial as a binomial squared. This is in the format x plus or minus b over 2, the whole thing squared. You can also use the multiply add chart to find the binomial if you prefer that. So I need negative 3, and that's going to be plus or minus the whole thing squared plus 1. And I'm going to simplify that back there. Negative 4 times negative 3 is positive 12. Now I should have filled in my open space here. And it says it's going to be b over 2. b over 2 is right here. 4 divided by 2 is 2. And then the last thing I want to do here, step 4, simplify the constants outside the parentheses. You should now have a vertex form equation. So negative 3, x plus 2 squared, plus 1 plus 12 is positive 13. And I'm also going to have us write our vertex here as well. Remember, our vertex is h, comma, k. And remember, h is going to be the opposite sign as it looks like. And there we go. Okay, I would suggest you pausing and seeing if you can do number 9, and then coming back and seeing if you got the right answer. Okay, welcome back. Here is our question. This one was a little bit shorter just because a was equal to 1, so I was able to skip step 1. I did go ahead and draw some parentheses just so I could see where I would have divided out my a from in these first 2 here. Then remember, we're just going to follow on from step 2. Step 2 said find b over 2 squared. I wrote that right over here. B over 2 squared was 8 over 2 squared, which would give us 16 because 8 over 2 is 4. And then it says, rewrite your problem with this value now inside the parentheses to make a trinomial. You must also subtract it from C at the end to keep the equation balanced. And that is right here. And then step 3, write the perfect square trinomial as a binomial squared. This is in the format x plus or minus b over 2, whole thing squared. You can also use the multiply add chart if you prefer. And that would be here, b over 2. I put a little arrow there. 8 over 2 is 4, so I put the 4 in right here. And then I just combine these because they were like terms into minus 4. I also wrote down my vertex, just a reminder the vertex is h, comma, k, where h is the opposite sign as it looks like. Oh, sorry. That's supposed to go here. And there we go. Same thing for this last problem. I would encourage you to pause, try to solve it, and then come back for the explanation. And welcome back. Here is number 10 if you want to check and make sure that you got it correct. My a value was originally a 3, so step 1 says to divide my first two terms, not my constant term, by a and write it down here. And then step 2 says find b over 2 squared, that's right here. So b, our new b, is negative 4. Negative 4 divided by 2 squared would be 4. And then remember, you're going to add it on the inside, subtract it on the outside to keep it balanced, because these would add up to make 0. But with this being on the inside of these parentheses, it would be multiplied by 3. So we have to multiply this one by 3 as well. And then I'm just going to simplify that a little bit here. Remember, this is a perfect square trinomial right here. I'm going to simplify that per step 3. Step 3 said write a perfect square trinomial as a binomial squared. This is in the format x plus or minus b over 2 whole thing squared. That's where I got this from right here. This is b over 2. Over here, my b value was negative 4. Negative 4 divided by 2 is negative 2. So my negative 2 goes right in there. And then I simplified this as well. This gives me negative 12. And then lastly, I'm just going to put these together into positive 4. If you would like to go from this one straight to this one, like simplify them both at once, I'm okay with that if you would prefer to do that as well. And then I wrote down my vertex. And my vertex is h, comma, k, where the h is the opposite sign as it looks like. And there you go. Good job.